Now the second question is e raised to 80 minus cos 3t by t. Okay. So here also you see that there is a denominator t, so you should apply frequency integration property. Okay. So we first write that property. We know that the Laplace transform of x of t by t is equal to integral s to infinity x of s ds. Okay, right? Here my x of t is e raised to 80 minus cos 3t. Okay, so therefore x of s that we require over here is the Laplace transform of this, which is the Laplace transform of this, that is Laplace transform of e raised to 80 minus Laplace transform of cos 3t. So the Laplace transform of e raised to 80 is 1 by s minus a. Okay, see, because it is here e raised to plus 80, so 1 by s minus a minus Laplace transform of cos 3t is s by s square plus 9. Okay, so all I need to do is simply substitute this in this equation and find the integration. That's all. Okay, so you will get the answer. So the Laplace transform of e raised to 80 minus cos 3t by t is nothing but integral from s to infinity 1 by s minus a minus s by s square plus 9 ds. Okay, ds. Okay, so here I know the Laplace transform of this. I'm sorry, I know the integration of this, right? The integration of this is log s minus a. Okay, so like I said before, I don't know the integration of this. I don't know how to find the integration of this. Okay, so let me first show you how to find the integration of this, in case if you forget the formula. Like I said before, it is always better that you apply the formula, okay, rather than doing this derivative. But since if you forget the formula, just simply apply this derivative and you have to be very quick about it. Okay, so what I'm going to do is I'm going to find the integral of this second term, s by s square plus 9. Okay, integral s by s square plus 9 ds. Okay, I want to find the integral of this. To find the integral of this, what I do is I just simply let s square plus 9 be u. Okay, let u is equal to s square plus 9. Okay, so if u is equal to s square plus 9, then what is du? Du is nothing but 2 into s into ds, right? So in other words, du by 2 is equal to s into ds. See, here the numerator there is s into ds. S into ds is du by 2 and s square plus 9 is u. So what will I get? I get 1 by u. Yes, 1 by s square plus 9 is 1 by u and s ds is du by 2 into du by 2, which is nothing but 1 by 2 integral du by u. We know what is integral of 1 by u, right? Integral of reciprocal is nothing but 1 by 2 into log u. See, 1 by 2 log u plus c. Of course, there is an integration constant. Okay, plus c. Here the c is equal to 0. That's all. Okay, so now we know what is u also. So simply substitute u over here. That's it. That's your answer. So you will get 1 by 2 log s square plus 9. See, this is how we find the integration of this equation. Okay, in case if you forget the formula. Alright, according to your formula, it is integral s by s square plus a square ds is equal to 1 by 2 log s square plus a square. Okay, So it's better that you apply that formula directly, because these steps that I have written over here, does not give you any additional marks. It's just for you to find the integration over here. Okay, so you won't get any extra step marks for finding the integration. You are supposed to know this equation. Okay, so this is how you do it. So in case you forget, this is the step you do. Just simply let the denominator be, let u is equal to s square plus 9, and then you apply the formula, substitute it over here, you will get this equation. Okay, but remember, integral a by s square plus a square ds is tan inverse s by a. For that you cannot apply this equation. Alright, so only for that, I meant about the fourth formula that you have learned. Okay, that formula you have to study as it is. The remaining you can do in this method. Okay, right. So now I'm going to apply this equation over here, and this, I know the integral of this is log s minus a, and this is 1 by 2 log x square plus 9, right? So I'm going to substitute that, or these things over here. I will get my Laplace of e raised to 8t minus cos 3t by t is equal to, okay, so integral of 1 by s minus a is log s minus a minus 1 by 2 log s square plus 9, x square plus 9, from s to infinity. Limits is from s to infinity. Okay, this 1 by 2 log s square plus 9 can also be written as root of, right? And if I combine these two log, then I will naturally get log of s minus a by this 1 by 2 is the power of this, so this will become root of s square plus 9 from s to infinity. Okay, okay, so now you see if you can make this answer not infinity. Yes, you can. You know how? By simply taking s common, right? We know that anything by infinity is 0. So if I want to make this s into a denominator of all the factors, then I simply have to take s common over here. That means take s common over here and take s common over here. Okay, so I will get log of taking s common from both numerator and denominator. So I will get 1 minus a by s by, and over here it will be root of 1 plus 9 by s square. Okay, from s to infinity. Okay, the reason I'm making for this is to find the value of this one. This value is the same, there's nothing to do over here, because the value is s, and just simply substitute s itself, you'll get the same thing. But to find this, I have to make this s into all the denominators. Okay, so that those values become 0. So in other words, this equation over here, now when I'm substituting infinity in this equation, I will get log 1 minus 0 root of 1 plus 0, which is nothing but log 1 minus, now if I substitute s over here, I will get the same thing, that is same thing over here, that will be log s minus a by root of s square plus 9. Okay, log 1 is 0, and minus of log s minus a by s root of s square plus 9 is nothing but, let me write it, 0 minus log of s minus a by root of s square plus 9, and this is nothing but reciprocal of this. If you want to remove the logs and the minus sign, so you should simply take the reciprocal. So this is your answer by s minus a. Okay, this is your answer. Okay.